Question 14. Create a graph that models the border relationships among the states shown in the map. Use vertices to represent the states and edges to represent the common borders. Okay, so we're not going to do anything with this model, like create a certain path or circuit. We just need to go ahead and represent it. So first thing we're going to do is have the vertices are going to be the states. So that means I'm going to have a vertex for every state listed on here. And then I'm going to create edges for the common borders. Okay, so anytime I have a common border, like between NV and ID, I'm going to have to create an edge between those. Okay, so I'm going to wait on drawing in my edges here because I'm going to write them on my model while I pick them out in the picture off the map. Okay, so first let's go ahead and get our vertices in there. So, I'm going to work left to right. There's more than one way, but I'm going to have one for NV. So there's a vertex. I need to have one for ID, UT, and AZ. It's not the only way to do these. There's other configurations, but all the vertices and edges should be the same regardless of how you draw your picture. Okay, now I need to have MT over here and WY, CO, and NM. All right, so now I've got all my states represented with the vertices. Now let's start putting in the edges. Okay, so like I said, NV has an edge. It shares a common border with ID, so that has to be an edge right here. So what else does Nevada have? So there's a common border here with UT, so there goes an edge. And there also happens to be one down here with AZ. So there is another edge. And if you look at NV, I've gotten all the edges in there. Any state it touches, that has to be an edge. Okay, I'm going to go through each state this way. Again, I like kind of moving left to right and top down. So I'm looking at ID. I've already got, this edge in here, but notice that it touches MT as well. So that has to be an edge. And it touches WY. So ID has to have an edge to WY. It also touches, notice right here I have a common border. So ID and UT have to have an edge right here. And now I've got all the states that touch ID. Okay, now I'm going to move down to UT. Now notice UT, I've already got two edges in here. So are there any other states it touches? Like, yeah, it touches AZ. So here comes an edge. Also, it touches CO. So I'm going to put UT to CO. Notice that UT also touches WY. So I'll have to have an edge between those two. And then lastly, UT and NM, they have this little corner that touches right there. So again, that gets an edge. All right, now let me go down to Arizona. AZ, so again, I've got this edge here, I've got this one here. Oh, there's an edge right here. So I have to connect AZ to NM. Are there any others? We said, yep, well, it looks like these two right here. They touch right in that little corner. So again, AZ, I have to create an edge between AZ and CO. All right, so now let me go through all these on the outside and on the far right and see if I've got any other states I need to include, any other edges. So right here, MT and WY have one. There's going to be an edge. And then I've got them all. It only touches those two right there. WY, I've got it connecting here, 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 but notice that it also touches CO. So I've got to have an edge here. And then lastly, I have, see how I've got it connected, a couple of them, but I don't have it with NM yet. So there's my last edge right there. Okay. So like I said, the picture on the right could be a little bit differently. I mean, there's nothing that says, what order you have to put your vertices in. Just lay them out in a way where, you can, draw the lines in there. You don't want to make it too difficult on yourself with that. Sarah is a high school student in Chicago. She will be going to college next year and is planning to visit the following campuses: University of Wisconsin at Madison, Harvard, and Ohio State University. How many different ways can she visit each of these schools and return to her starting point? So we're asked for how many ways can she visit each of these schools and return to her starting point. So what we're looking for is a circuit, right? So we're looking actually for a Hamilton circuit because I want to visit every city. So if you think of the cities as being vertices, then we're looking for a Hamilton circuit. So we have, let's see, the cities that we have. Well, we're starting off in Chicago, and then we need to go to University of Wisconsin, and we got to go to Harvard and Ohio State, and then we're going to go, back to Chicago. So I have 4 vertices. And again, think of this as being a Hamilton circuit, since I want to visit every vertex, which is a city. Well, the formula for that is n minus 1 factorial, where n is the number of vertices. So here I've got 4 minus 1 factorial, or 3 factorial. And remember, the factorial is 3 times 2 times 1, so we end up with 6. So there are going to be 6 ways that she can go ahead and visit these 4 colleges, starting in Chicago and returning in Chicago. Okay, so for question number 35, there, we have Mark who's going to go ahead and visit a number of different departments, and they give the cost of each of these. And then the question is what is the minimum cost that he can pay to visit all the schools and return to Tulsa? So if you think of the schools, each school is a vertex, then we're looking for a Hamilton circuit. Okay, so for this particular question, we're going to have to first go ahead and set up our graph, and then we'll decide which method we want to use to go ahead and find the minimum. So either the nearest neighbor algorithm or the brute force method. So first, let's go ahead and set these up. So we know that the 4 schools he has to visit, well, we're going to start off in Tulsa, right? So I'm going to have Tulsa. It's going to be a vertex. And then I want to go to Berkeley. So B is going to be a vertex. And let's see, I also want to go to Madison. And then we have Chicago, Illinois. Okay, so those are going to be the 4 schools he goes to plan to visit. So now let me go ahead and put the weights on their edges. Okay, so let's see, so he visits chemistry. Okay, so Tulsa to Berkeley costs $604. So Tulsa to Berkeley is $604. And then Tulsa to Madison is going to cost $510. We have Tulsa to Chicago. So Tulsa to Chicago will be $490. And Berkeley to Madison is $818. So Berkeley to Madison is $818. And let's see, Berkeley to Chicago. So Berkeley to Chicago is $699. And Chicago to Madison is going to cost $105. Okay, so first we got to get our model done. Okay, now we're going to go ahead and, like I said, we are looking for a Hamilton circuit because we want to visit each school and return to the same school. So we're looking for a Hamilton circuit. Okay, now as we saw in the previous example, since I have 4 vertices, there's going to be 4 minus 1 factorial, so 3 factorial, or 6 possible paths. So 6 ways or 6 paths. So if I use the brute force method, that means I'm going to have to look at all 6 paths and then go ahead and tally up the cost of all 6 paths. So I'm going to go ahead and work it out for you both ways. Okay, let me go ahead and I'm going to work out the brute force method way first. So again, let me go ahead and write that down. So brute force method. That means I have to find all paths, compute the cost of each path, and then pick the minimum. Okay, so we already said that there are going to be 6 paths. So, and if you have a question about how we get the paths, you can go ahead and ask me about that. So one path would be, and again, we're always going to go ahead and start right here in Tulsa. So I can go from T to M to B to C to T. Another possibility would be from T, then I'll go to B to C, M to T. And I could go TB, then I could hit M, and then C, and then T. Let's see, I can go from Tulsa to Chicago, and then I would go BMT, or Tulsa, Chicago, MBT. So these are my, let's see, did I get them all? One, oops, and I gotta get, let's see which one I missed. Oh, I missed TM, CBT, CBT, okay. So here are my 6 different paths. And I'm gonna go ahead and compute the cost of each one. So, like I said, for instance, let me go ahead and just take this first one here. Or this last one here. So when I take this one here, I'm going to start here in Tulsa, and I'm going to go then to Madison. So that's going to be 510. And then I go from Madison to Chicago. That's going to be 105. Then Chicago to, let's see, that was Berkeley. So that cost is $6.99. And then I go from Berkeley back to Tulsa, which is $6.04. When I add up all of those, I get a total of $19.18. So $1,918. I have to do the same thing for all of the paths. Okay, so I went ahead and I worked that out already. So this first one is going to be $25.17. And I get $19.18. Then I have $20.17. I got $25.17 and $20.17. And this last one was the $19.18. Okay, so which one is the smallest? Well, we got right here, $19.18, or this one here, $19.18. So the minimum cost is going to be $1,918. If they ask me what the flight, what the order would be, I could list either one of these since they're the same. One more note about this, like this is the brute force method. It will always give you the absolute minimum or maximum. The bad thing is the more vertices you have, the more paths you have to consider. Or you could end up with hundreds of these, and you don't want to have to calculate those all by hand. Okay, now I'm going to do the same problem. We're going to use the nearest neighbor algorithm. Okay, so the nearest neighbor algorithm, like I said, I know I'm starting here in Tulsa. So look at all the edges out of Tulsa. Which one is the cheapest? So I've got, 510. I've got 604, or this path coming down here. Oops, that one was 490. So which one of those is the cheapest? The 490 is. So I'm going to do this edge first. So I got 490. And again, I'll just keep track of it here. So T to C. All right. Now I'm over here at C. Which edge is going to be the least expensive after this one? So I basically have 2 options. I can go from C to B, which is $6.99, or I can go from C to M, which is $105. This one is cheaper, so I'm going to take that route. So I'm going to go from C to M, and that's going to add $105. Okay, now I'm at M. I only have one choice here because I need to from M to B, so that's going to be $8.18. And then my last edge, I have to get back to Tulsa, so I have the 604. Adding all those together, I get 2017. So it may not have been the overall least expensive possibility, but I was able to do it rather quickly. And like I said, with the brute force method, I had to find the 6th path, compute the cost of each path, and then pick the least amount there. Number 44. A corporate campus plans to run a computer network cable between buildings. Use Krustal's algorithm to find the minimum spanning tree that allows the network to connect all the buildings, and then how much cable is needed. So we want a minimum spanning tree. Okay. And then we want to go ahead and make sure that we connect, all the buildings. So a minimum spanning tree, remember, I'm going to go ahead and I have to hit all the vertices. So, hit, all vertices. I should say every vertice. Okay, you have to hit every vertex. If I'm going to have a minimum spanning tree, that means I should have no circuits as well. Okay, so when I'm creating this, I'm always going to go ahead and start with the least expensive, and then just keep adding edges until all the vertices are hit. And when I have a choice to make, I'm going to pick one that is not going to create a circuit. So if it's weighted, I'm going to pick one that's less. And then again, I never want to create a circuit. Okay, so looking at all of these here, I can start with any of them. So just which one is the cheapest of every edge out here? So looking around, 95 is right here. So 95 is going to be the cheapest, the least expensive. So I'm going to start with that one. So it is connecting admin to customer service. So that one is now gone. So I don't need, you know, like I said, that path's gone. Now I got to start adding some other edges because right now I've only got 2 of them done. Okay, so what's the next one after that? Who's the cheapest? So I keep looking around. I've got 112 is the least expensive. And again, if I use 112, connecting these two here, that's fine because I haven't created a circuit yet. Okay, so I'm going to keep going. The least expensive after that one, let's see, so I've got, looks like 145. Okay, so again, connecting these two edges here, I'm fine. I haven't created a circuit yet. Notice that, you know, I'm going from, you know, research, I got admin, I got this one here, I got this one here. What have I not touched yet? You know, and I'm like, well, I haven't hit marketing at all yet. So I got to make sure I get marketing in there. So the next thing I look for, well, like I said, marketing, I've got a couple options. I could either do the 174 or the 215. This one is cheaper. It does not create a circuit. So that's going to be the one I want to go with. Right, whoops, so let me add these in there. So I had 75 plus my 112 plus my 145 plus 174. And so that gave me a total of 526 feet. So I need 526 feet of cable. Okay. And then the ones I need to cover are going to be these right here. So this one, this one, this one, and this one. So that'll give me my minimum spanning tree. With this particular example, we never really had to make any difficult choices. So it's like I said, it's worth looking at some of the others. And if you've got, you may have an edge that has a lower number, but it would create a circuit. So we wouldn't choose that. So like I said, the main thing is start off with the least edge and keep adding, you know, edges so that every vertex gets touched, but that you also don't create any circuits.